Hi. I think my theme is gonna be a theme of my channel, to bring physics into a lot of areas where it is not traditionally supposed to go. I'll take it there anyway. Cutting back to the whole relativity thing, because that is it's a rather complicated thing for us to understand, mainly because we don't experience relativistic effects every day, so we're not used to it, we didn't learn it, we cannot have troubles grasping it, so have a different way of looking at it. And it's a very old metaphor that time is like a river, and you could say that the river flows and time flows by you. And you could say that the events are things that are floating in the river. And the things you can see in your now is just a line across the river, and a line you cannot look further back upstream, because that would be the future. You cannot look into the future, and that line is the now. And you can see things that flow past to the now, and these are your observations of events. And by recording them, you could conclude that then now they must be so far downstream, or they are in the past, basically. So the past has not the uncertainty. If you didn't record it, you cannot know it, but it does not have the uncertainty of the future, because you cannot look across the line. You don't know what the stream will bring across this line of now. But all human observers stand next to the same river, and they have the same now, because they don't have a relative speed towards each other. That means they have the same frame of reference. And it brings the trouble that people can have the craziest theories about what causes these events to occur in the now. So you could have someone having a theory that says there is an elephant standing on the shore a little bit upstream of this line we can look at, and he is with his trunk throwing events from a big pile of events into the river, and that's how they arrive in our now. And you could no way refute this, because we all have this same line we can look over, and we cannot see the elephant because it's a little bit upstream, and we cannot see that. Until relativity came along, because relativity allows you to have a different now, and to look a little bit upstream from someone else by having a relative speed and accumulated over a certain distance. So if you synchronize watches, and you go to the Andromeda Nebula and look with a big telescope to this other person's life, you can look a little bit into his future. And when you write down what is going to happen, what is happening, and you come back together and you make a timetable of what happened, then you can prove that what he thought at a certain moment to be thrown into the river by the elephant, so a few seconds into his future, was already in the river in your now. You could already see that in the river. Your line of now was a little bit rotated compared to his line of now. So you could look a little bit upshore from his now. And that's how you can prove that there is no elephant on shore throwing events into the river of time. And you can make this distance arbitrarily large by enlarging speeds and distances, but you can never warn him. Say that suppose you can already see that someone of the all-male Christian debating club is going to ring his doorbell. You cannot call him or send him any signal to warn him for that event, and prove that it was already in his river, because the speed of light prohibits you from, when the message reaches him, it's already too late. The same thing is with causality. If you have two events, A and B, and when with a certain line, it could be that A crosses it first and then B. So you could say A was first and can cause B, but not the other way around. If you have a different frame of reference for a different observer, he has a different line, you could have that these events come across his line in a different order. Then you could say, hey, how is that? Now B can cause A, but not the other way around. What causes what? It proves that you can only accomplish such a situation when the two events are outside their causation range. So what is the causation range? It is something on Mars, an event on Mars right now is out of my causation range, because anything, whatever I could do, it will take at least 12 minutes or so to reach Mars, and I could in no way influence it. So only events that are outside of a range of causation can flip around in order from a different perspective, from a different observer in a different frame of motion. Now, Einstein was, of course, a determinist, and he had a decade-long debate with Niels Bohr about this thing, about whether determinism or indeterminism rules. And Einstein got into trouble in the end of this debate because of some developments in quantum mechanics. And he either had to give up determinism or had to give up the idea of locality in physics, so that things cannot act instantaneously on a distance. And which he also thought very spooky, it disturbed him very much. And in the end he rather gave up determinism and hold on to the local universe than the other way around. But this in no way means that that it gives any room for free will, because all his opponent in this debate, Niels Bohr, argued was that things were random. So they had a certain statistical chance of occurring, and this in no way has any relevance to free will. You cannot get to free will, which is basically a dead end of causation. In a way, it is a bit like the old debate during The Wizard of Oz. When The Wizard of Oz was written, there was a big debate going on whether you use gold or silver money. And there was a small group of people who advocated paper money, and everyone thought they were kind of crazy. But in the end, they won out, not the debate, but they gained more power. That was about a different view, maybe more understandable view of the determinism viewpoint with relativity brought in. Okay, feel free to leave any comments. Thank you very much.